In this video, I'm going to talk about the asymptotes of a very simple and classic function. So that function is f of x is equal to 1 over x. How does the function behave as x approaches positive infinity or as x approaches negative infinity? And we will also investigate if there are any other asymptotes for this function. So this is x and this is y. If you sketch it, by the way, this is how it's going to look like. And this is how it's going to look like. They are reflections of each other. Now, let's go ahead and break it down into a few pieces. So let's say case number 1. Case 1. What happens to the function f of x or 1 over x as x approaches positive infinity? What happens to 1 over x? 1 over x approaches 0 from the top. Remember, it's getting smaller and smaller and smaller. And it approaches 0, which means it approaches the x-axis. So that's case number 1. And it's a horizontal asymptote because it's approaching a horizontal line. So this is a horizontal asymptote. Case 2, as x approaches negative infinity, what happens? Okay, to 1 over x. By the way, 1 over x still approaches 0, and that is also a horizontal asymptote. Remember, how does this happen? So look, you have, let's say x is equal to negative 2 and x is equal to negative 3. So your function values are going to be 1 over negative 2, comma 1 over negative 3. Now, this is where sometimes people make mistakes, and I am guilty of making that mistake as well. So let's say this is my 0, this is my negative 1. So my negative 1 half is going to be right in the middle, negative 1 half, and negative 1/3 is going to be somewhere here, negative 1/3. So without kind of taking into consideration the sign, we kind of quickly say that, oh, negative 1/3 is smaller than negative 1/2, which is incorrect. Actually, negative 1/2 is smaller than negative 1/3 because it is to the left of negative 1/3 on the number line. Remember, on the number line, if a number is to the left, it is considered smaller. If it is to the right, it is considered bigger. So on the in the case x approaches negative infinity, the function still approaches 0. However, it approaches 0 from below, or the function is increasing. In this case, the function is increasing as x approaches negative infinity. And in this case, as x approaches positive infinity, function is decreasing, still approaching the same line. So in both of these cases, horizontal asymptotes are going to be the line y is equal to 0 or x-axis. X-axis. Now let's consider case number 3. Case 3. What happens to this function as x approaches 0 from the positive side? So x is getting closer and closer to 0. Again, as you can see, if in the denominator of 1 over x, it gets smaller and smaller and smaller from the positive side, this is going to approach positive infinity, right? Positive infinity. So in this case, however, we have a vertical asymptote. Vertical asymptote. And what is the equation of the asymptote? Which is going to be the line x is equal to 0 or y-axis. And case 4 is going to be as x approaches the point 0, but from the negative side. In that case, what happens to 1 over x? Look, it's approaching from the negative side, meaning that all the numbers, all the x values are going to be negative. If x values are getting closer and closer and closer to 0 from the negative side, what happens to 1 over x? It approaches negative infinity. Again, it's a vertical asymptote and it approaches the same line, which is the y-axis. In one case, is going towards positive infinity. In another case, it is going towards negative infinity. I hope that this discussion was helpful. Thank you very much.